Hello everyone, my name is Luke Jonker. Today I'll be presenting my capstone project. I did it on comparing the growth of Oscillium bacillium Genovese basil for short. I compared the height and the number of true leaves using two hydroponic systems. I used the vertical tower system and the nutrient film technique, or NFT for short. This project was completed at the UF Horticultural Teaching Gardens with support from the UF and IFAS greenhouse staff, and it focuses on understanding how different hydroponic systems influence plant growth within a controlled environment. So hydroponic agriculture continues to grow in importance as growers look for ways to maximize yield, reduce water loss, and make production more efficient, especially in areas where space is limited, like urban environments. Vertical and hydroponic systems each offer unique advantages. The vertical towers, for example, they can reduce horizontal footprint, or space for short, and which is helpful for maximizing your production. The vertical or the horizontal system, the NFT system, offers consistent nutrient delivery on a horizontal platform. Despite these known benefits, there's actually very limited and almost no published research directly comparing Genovese basil between the NFT and vertical tower systems, especially with same nutrient and lighting. Because of this gap, growers and educators don't have much guidance on how these systems perform relative to each other. My project hopes to fill that gap by providing a direct comparison of both systems under matched nutrient and lighting conditions using measurable growth patterns. How does Genovese basil growth measure in height and number of true leaves differ between the vertical tower system and the NFT system under similar conditions? So the materials I used for this study, well, the plant I used was Genovese basil, or Oscillium bacillum genovese, the scientific name. It is a very common basil variety, both used in hydroponics and culinary. The systems, I used the UF Horticultural Teaching Gardens vertical tower system, which is located outdoors, and the NFT system, which was inside the UF IFAS greenhouse, where the temperature is more controlled. I used the same lighting and nutrients. For the nutrients, I used Jack's 5-12-26 mixed with calcium nitrate. I also used grow lights for both systems that were running 24 hours a day to help maximize the growth in a short experimental time period. For the experiment itself, I originally wanted 15 plants per system, but due to germination issues, only 12 seeds germinated, meaning 6 per system. Throughout the 5-week experiment, I recorded weekly measurements from the base of the plant to the apex. I also recorded the number of leaves and the plant's survival. A major factor influencing this study was the environment. Unfortunately, the vertical tower system could not be placed inside the greenhouse, meaning it was exposed to a few freezing nights. Meanwhile, the NFT system remained in a climate-controlled greenhouse where the temperature stayed consistent and moderate. So my results are, over the course of 5 weeks, the NFT system consistently outperformed the vertical tower system in both plant height and the amount of true leaves. The NFT plants continued to grow steadily after week, while the vertical tower systems grew the first 2 weeks and then eventually plateaued and declined. As the temperatures dropped outside, the vertical tower plants experienced visible stress and eventually declined. By week 5, there was only 2 surviving plants left in that system. NFT system, plants remained healthy. These results clearly show how growth diverged between the two systems, and the graphs and photos from the poster help illustrate this. These are my graphs from the poster board. This is the average growth measurements. Over here we've got the NFT height, which is the solid line, the orange solid line, and then the NFT true leaves, which you can see it slowly rises up. And then in the blue, we've got the solid line. It shows the vertical tower height, and the true leaves in the dotted lines, which as you can see, it's a very big difference. And these are just the height and true leaf count growth comparison chart. The main reason the NFT system performed better was because of the environmental stability. Even though both systems use the same nutrients and lighting conditions, the outdoor temperature fluctuations, especially during the freezing nights, had a major negative effect on the vertical tower plants. This shows that even if the vertical system has a theoretical design advantage, such as space efficiency, they can be completely overshadowed if the environment is not controlled. The NFT system benefited from the stable greenhouse conditions, which allowed the plants to grow continuously without environmental stress. From this project, there are a few takeaways. Environmental control is absolutely critical in hydroponic production. The NFT systems offer a greater temperature stability when used inside of a greenhouse, whereas the vertical tower system may be sensitive to cold temperatures, especially if it is outdoors in the open air. Overall, environmental differences can matter more than system design, meaning that even a well-designed system won't perform well under poor environmental conditions. If I were to repeat this experiment, I would make several improvements. Number one, I would definitely place both systems in the same identical environments so that the environmental differences wouldn't impact the results. I would also increase replication because having more plants helps make stronger data. I would also ensure that the nutrient levels were monitored and maintained equally throughout the entire study so that there are no changes. And I would also add more measurements such as root health, nutrient uptake, and possibly even chlorophyll levels, since these could provide more insight on how each system affects plant physiology. In closing, thank you so much for taking the time to listen to my poster walkthrough. This study demonstrated how important environmental stability is in hydroponic systems and even how small differences can change the plant's growth drastically. I hope this comparison provides useful information for growers, research, and anyone else interested in controlled environment agriculture. Thank you.